Welcome to this first public webinar from the HEIMDALL project. The objective of this webinar will be to introduce the general idea behind the HEIMDALL system, to introduce the approach, the concept, and to provide some information about the service concept, which has already been developed, and the first version of the system architecture as first outcomes of the project. So first of all, we are going to have a look at the outline for today's presentation. We will introduce the objectives, the consortium, the concept behind HEIMDALL, and the approach that will be followed during the project. And then we will focus on the particular cases that will be addressed by the project. We will explain what is the relation with the decision-making process used by most of the stakeholders within the consortium, and how the system concept adapts to it, and how the system architecture supports the idea behind the service concept. So first of all, HEIMDALL stands for Multi-Hazard Cooperative Management Tool for Data Exchange, Response Planning, and Scenario Building. And HEIMDALL is a European project developed in the frame of the Horizon 2020 program, which started in May 2017 and will last 42 months, which means that the project will end in October 2020. The main objectives of the project is to develop a series of services and products for response planning and scenario building, but not only for response planning and scenario building. Let's say that this would be the main focus, but that the system is intended to address the different phases of the emergency management cycle, understanding mitigation and preparedness, response, and recovery. And for that, we will have a series of tools which are going to be integrated into a multi-hazard federated platform that we will see in the next slides. The overall idea of the project is to design and develop the system as well as testing it. And the final objective is to demonstrate the system prototype using an operational environment with the cooperation of the different stakeholders, which are partners of the consortium. So having a more detailed look at the objectives of the project, these were in the previous slide, the overall objective was presented. Now we are going to have a more detailed look at the detailed objectives, and one of the main ideas behind this federated platform is to have a collaborative system for experts to be able to exchange information among different entities and organizations, even developing their activities in different countries. And for this, we are not only addressing one type of emergency management organization, but we are addressing different emergency management profiles. And for that, we will address the necessities and the requirements from different end user perspective. The system, in order to provide the services, will make use of different tools to be integrated as inputs, and basically these inputs will be mostly based on satellite information provided by in-situ sensor, also aerial-based data provided by drones, and field information which can be provided, for instance, by first responders on the field. Furthermore, we will gather this information and we will process it using using a series of different tools based on hazard modeling, information fusion, situation assessment, and decision support. And based on that, the end users will be able to take a funded decision and to communicate this decision to all the relevant stakeholders, including first responders on the field. The scenarios that are going to be addressed by the system, although the system should not be, let's say, it's not intended to be limited to a dedicated type of hazard in the long term. For the duration of the project, the scenarios that we are taking into account are forest fires, floods, and terrain movements. And the tools to be provided have to be input into a scalable and modular platform that will allow the incremental development of the system, adding new tools as soon as they are available. Finally, apart from that, we will take into account the business and innovation concepts in order to analyze the sustainability of the system and make it sustainable by the end of the project. And we also take into account ethical and human factors as well as societal acceptance. So these are basically the overall objectives of the system. Now we are going to see who are the people dealing with the project. We have a list of 14 partners in different European countries, and these partners cover a wide range of expertise fields, ranging from the technical partners to the social sciences partners, and including, and this is very important, a high amount of practitioners within the consortium. So for this project, we have actually 5 different profiles of practitioners. We have firefighting units and the police department, which is being coordinated and provided by the Department of Interior of Catalonia. We have also civil protection units, which is being provided by the fire and rescue services of the Frederiksborg region in Denmark. We have also medical emergency services represented by the Italian Red Cross, and we have also the command and control centers represented by the Scottish Fire and Rescue Services. Okay, having seen who is participating in the project, we have here the first idea or the first hint about the HEIMDALL concept. So the idea that we have in mind and that we will develop is to provide what we call a local unit that can be used or managed by different organizations. And for every local unit, as you can see, we will have a central element, what we call the integrated service platform, which will include inside, we will have different tools to be provided, like scenario management, modeling and simulation, risk and vulnerability assessment, situation assessment, and decision support, so that the users can access this platform and make use of the different tools. In order to make use of the tools, we will have different data sources. On one hand, we have like data sources provided by space-based data, ground-based data, and aerial sensors. So this data will be integrated. And also we will provide interfaces to external systems, like for instance, the systems currently being used by different organizations could be interfaced to the system, or weather services or any other type of service which could be relevant. Based on this, we'll have different local units, and our idea would be to make use of a federated architecture so that the different local units in different organizations or managed by different organizations and by different countries can dialogue with each other, can be interconnected to each other by means of a global catalog. So the idea would be that every local unit can provide different data, different services, and publish in this catalog what are the data and services available, so that people or end users accessing the system or connecting through other local units can access the catalog, be aware of what is the data and the information available, and access it directly through the corresponding interface. So this would be the concept as a whole. And now I'm going to provide some information about the HEIMDALL approach. We are using the V model for the system engineering. So we go from the upper part of the V on the left, from the requirements analysis, functional analysis, to the implementation, and then we go the other way around to perform integration, verification, and system validation. And we use this approach in order to have an iterative and incremental development. So we will use this approach 4 times in total within the system in order to have 4 system releases, what we call release A, B, C, and the final release. And in each release, we will have an incremental development so that we are adding more tools and more features to the system. Together with that, we will have periodical end user workshops with a tailored community of end users, what we call our advisory board, and we will sit together for every system release. Actually, we sat together already for gathering the requirements. We will have some additional end user workshops which are co-located with the different system releases, so that we get feedback from them and we can improve the system for the next release. So this was everything from my side. So now my colleague Benjamin Bart will take over the presentation and we'll go on with the following slides. Thank you very much.
Thank you, Javi, and welcome everyone. Let me quickly take over the controls of the presentation. Yeah. So I'm going to present you an overview of the use cases and the service concept and the system architecture of Heimdall that has been developed in close interaction with our end user partners from the project and the advisory board. So let's start with the use cases right away. It will be possible to use the Heimdall system in two operation modes. The first one is the preparation mode, in which end users can conduct response planning and scenario building using hypothetical and historical data that either is stored in the system or shared by another entity. In the second operation mode, in the response mode, in this mode, actual sensor data of a real ongoing incident is used as an input, and this can then be evaluated and used by firefighters or the medical services and so on. HEIMDALL is a multi-hazard platform, which means that it has the capability to be extended for basically any kind of hazard, natural or man-made. However, during the project, we focus, as presented, on the main hazards: forest fire, floods and flash floods, and landslides. We further consider cascading effects like flood triggering a landslide blocking rivers, and with this increasing the probability of a flood, a forest fire damaging a dam, which increases the probability also of floods, and a landslide damaging high voltage power lines, which increase the probability of forest fire afterwards. So now to the service concept of Heimdall. We have investigated the decision-making of practitioners with the support of our end-user partners, and it turned out that they all have their own models that they're asked to follow during disaster situations. Like, for example, the fire and rescue service from Scotland, they follow the judgment and decision-making model. And we've tried to combine this with the modular observe, orient, decide, and act model and other normative models in a single picture that is shown here. We found, for example, the situation assessment phase, SA, here in red. That consists of gathering the information and intelligence and partially of the assessment of the risk and the development of a working strategy. So the big cornered boxes are steps to be taken by the end users. And in the background, we have the dedicated phase, here in this example, the situation assessment. The small cornered boxes are the results of these steps. So the gathering of information and intelligence, the result is a situation or a simulation in this case. Afterwards, we will assess the risk and develop a working strategy, which results in a strategy in general. As a next step, end users consider the powers, policies, procedures, and get some constraints. And with this, they get some constraints. And afterwards, they identify their options and contingencies and having a plan or a decision. As last step, they take and coordinate an action which results in an action or in a lesson. So we took this model and we investigated how can the Heimdall system support end users in their job in responding disaster situation. And we basically came up with this. So here we see that each step and phase assigned a functionality provided by the Heimdall system that supports in each step. We have data sources like the drone detection system, in situ sensors for landslides, and simulation tools that help with the gathering of information. A situation assessment functionality that includes, for example, risk and impact assessment tools, scenario management functionality, and the provision of an impact summary, which helps to find a strategy. A scenario matching tool on top of this then helps us to find a similar scenario in the database to check how we have been reacting in similar situations before, and by chance fasten up the process of response planning. The HEIMDALL data sources can further be used for checking powers or store policies, and therefore help with this step to find the constraints for the current situation. Decision support functionality can, for instance, show different options for shelters and help to find a good decision and make a plan. On top of all of this, communication and information sharing supports the end users at each step, first in taking and coordinating the action, for example, with the first responders in the field, but each step can be supported by information exchange within the own organization or with other authorities involved also in the incident. So how does it look then from the technical perspective? Here's the system architecture of one local unit that has been explained by my colleague already, but here it is shown in more detail. I have to add that this is a preliminary version, and the architecture is still under progress, but is already quite advanced at this stage of the project. The picture shows the technical models that we're going to implement and integrate. And you can basically see the local unit that is marked here by the big gray box in the center. On the left-hand side, we have the system inputs that have already been explained by my colleague. Here we just have the difference that we all distinguish between data that is directly provided to the user via graphical user interface, or we have a process module that, for example, provides products derived from satellite picture data, like burn scars identified by the system. We have a simulator module that consists of 3 simulators adapted to our 3 hazards we're considering. So basically we have a simulator for forest fire, for floods, and one for landslides. The simulators is used by the risk assessment, by the impact summary generation, and by the decision support tool to provide their products. In the lower part of the architecture, we have the scenario management tool, which is a core module that enables the users to manage the different scenarios and response plans of the system. The user role and management with access control ensures that only authorized personnel has access to the data and provides security for the system. As I said, a graphical user interface will provide the user the means to display the data and to control the system. On the right-hand side, we have everything which end user needs for communication. There is an information gateway that helps us informing the public and stay connected with the first responders in the field. For this, we can use a satellite communication channel or the general internet as a connection. And further, we have a catalog that helps with information discovery and supports it interconnecting to other authorities. And then last but not least, in the center, there is the core element, the service platform that interconnects all modules of HEIMDALL. And yeah, with this architecture, I would like to close the presentation. We have shown you the objectives and the concept of our project and presented the service approach and the technical architecture. And yeah, finally, I want to say thank you to all listeners. And if you have, after the questions answer, also some questions, here are the contact details of the new project coordinator of HEIMDALL, and also you can find my details below here.